Welcome to another video in MCV4U. In today's video, we'll be talking about intro to limits. Limits are basic to all of calculus, and the process of finding of the limits of functions is very important. The limit of a function is the y value, or the behavior, that a function takes near a particular x value. The statement limit x approaches a, f of x is equal to L, as I just read out, it's read as the limit of the function f of x as x approaches a is L. So here, this represents as x approaches a. So let's look at an example of a limit. So determine the limit of a function y is equal to square root x as x approaches 1. So now we're given a statement. Let's write it in the notation that we just saw. So we first write limit. Now x is approaching 1, so that replaces the a value. Our function is not f of x. Now our function is square root x, and it equals 1. So that is the graph that's seen here on the right. And really, we see these limits, they can go in two directions. So if you think about this particular example, the limit can approach from the left side or the right side. And as we see here, when we approach from both sides, as x approaches it from the left side or right side, it both touches 1. So here, the limit of a function is not concerned with the exact y value of a function at a given x value, but rather the tendency in the y values as x approaches a specific value. So as I was mentioning, again, we can approach these values from two sides. So we can approach it from the left and the right. And so now we're going to talk about left and right hand limits. So these limits are used when the behavior of a function is different on either side of the indicated x value. If we look at the example at the top, we see that whether or not it goes from the left side or the right side, whichever direction you go, it ends up going to 1. However, that's not always the case, and therefore we have to use left hand and right hand limits. So these limits are used when the behavior of a function, again, is different on either side of the indicated x value. So left-hand limit approach it, x is equal to 1 from the left. So the graph is on the right-hand side. So just highlight that. So the graph is here that we're looking at. And the functions are provided to us. And so here, when we're writing our notation for limits, anytime you have a value and you have this negative sign, that means it approaches from the left. So here we have 1 minus, which means that it approaches from the left. Anytime you see a positive value, so 1 positive or 1 plus, this means that it approaches from the right. So let's look at this. So limit of 1 negative of f of x, right, at x is equal to 1. So let's see here. So if we go from x is equal to 1 and we approach it from the left side, we see that we would get a value of positive 1. So we see right here, this value right here of positive 1. if we go from the right hand limit, approaching it from the right hand side, we see that it approaches -1. If we look at the limit from 4 negative, so it's going from the left side, so from 4 negative, and from 4 positive, they both go to positive infinity. So when does a limit exist? So there's a few conditions that need to be met for a limit to exist, and this is important. So as limit as x approaches to a of this function exists if and only if the following three criteria are met. First, there has to be a limit from the left-hand side that exists. There has to be a limit from the right-hand side that exists. So let's just write that. So here, so limit from the left-hand side must exist. Here, the limit from the right-hand side must exist. And finally, here, the left hand limit must equal the right hand limit for the limit to exist. Okay, so if we look at this, so returning to that example, we saw that the limit as x approaches 1 from the left was +1, but when we looked at x approaching 1 from the right hand side, we saw that it was -1. So we see here that they are different. And so again, that means that this limit does not exist. And so we can write it as DNE or does not exist. Okay, and in this situation, the reason that's the case is because the left-hand limit does not equal the right-hand limit. And then let's look at the limit as x approaches 4. We see that both the left-hand and right-hand limit are the same, and they both exist, which means that we can see that here it goes to positive infinity. Okay, so let's look at an example where we look at some different values here. So again, use the function y is equal to f of x defined by the following graph to find each limit. So let's look at the first one. So this is the limit as x approaches 4 from the left. So x approaches 4 from the left. So do this in blue. And so we'll see that that's here, and I'll label this A. So here, this limit as x approaches 4 from the left, we see that the value is 1. The limit as x approaches 2 from the left side as well. So I'll do this in red, and that's B. That will be equal to 2, which will be right here. The limit as x approaches 1 from the left side. So x approaches 1 from the left side. You see that that would be here. Let's do that in orange. C, we see that that reaches at 2. The limit as x approaches 3 from the left side. That's right here. This is D. We see that that would be 1. Okay, let's continue. The limit as x approaches -1 from the positive side. So as x approaches -1 from the positive side, that is e. So we see here, let's do this in green. This would be e, and we see that that would be equal to 1. Limit as x approaches 3 positive, right? X approaches 3 from the right-hand side. That would be right here. And let's just do that in black. And so that's f. And here you see that it goes to positive infinity. Limit as x approaches 4 from the right-hand side. As we see here, it's pretty much off the page, or you can't see it. So here it would, let's write dne, does not exist. Then finally, limit as x approaches -2 from the right-hand side. This little green color here. So that would be h. We see that that would be at 2. So there's different types of limits. And so the first one is finite limits. And again, this is if this limit as x approaches to a for the function f of x is equal to L, means that f of x is close to the number L. This is the most common type of limit. So if we see here, we see from the right hand and left hand side, we see that here it approaches closer to the value of 2. So we see we can write this as the limit as x approaches 6, f of x is equal to 2. However, that's not always the situation, and there are other types of limits that we'll look at right now. So infinite limits always occur for a finite x value, which means that it's around, for example, a vertical or horizontal asymptote. So it will always occur for a finite x value. Sorry, just around vertical asymptotes here. So, so finite x value example around a vertical asymptote. So here, the limit as x approaches a for the function f of x equals positive or negative infinity, that f of x grows without bound. Okay? And here, eventually becoming bigger, smaller than any number you can name. So remember, inf infinity is not a number. Rather, infinity is a process of growth that never ends. This means that the limit does not exist. A limit simply expresses the overall trend of a function. So remember, if we go all the way back to the very beginning where we're looking at it, the limit of a function is not concerned with, again, the exact y value of a function at a given x value, but rather the tendency in the y value. So that's what we're talking about here as well. So for example, 1 over x squared can be made as large as we like by taking x close enough to 0. So here, we know that x provides us with a number, and here, y goes to positive or negative infinity. So here we can write the limit as x approaches 0 of this function f of x is equal to infinity. So see, as it goes from the right side and the left side, it goes to positive infinity. However, right, it gets to this value that it gets really, really close to 0, but never actually touches 0 here. So again, that's the tendency or the trend that it's going to. And then finally, limits to infinity always occur as x values get very, very big or very, very small. So for example, plus or x goes to plus or minus infinity. And this again here is around the horizontal asymptotes. So infinite limits, vertical asymptotes, limits to infinity will be the horizontal asymptotes. So here, x again will go to plus or minus infinity, and the y value will go to a number. So here, again, it's through the horizontal asymptotes. So we see here, the limit as x approaches negative infinity. Oh, can't draw infinity. So as x approaches negative infinity, here f of x is equal to 2. And on the other side, the limit as x approaches positive infinity, f of x is equal to 2. So again, there's that horizontal asymptote. Let's underline this here. And that would be the horizontal asymptote. And they they continue to go both to 2, very close to 2, but never actually touching 2. But that's the tendency of the function.